Okay, and hi everyone, my name is Andrew, and today I'm going to talk about this animation, the Mobile Suit Gundam Charge Counterattack. And this is published in 1988, quite old movie, maybe. Okay, it's directed by Yoshiyuki Tomino, and it's made by an old studio called the Sunrise Studio. Okay, and this story is about a man. Okay, a world has a near future of the Earth has begun colonized in the space for around a century, but there's still a lot of world nearby for these 100 years. And today I'm going to talk about it in UC 0093, the universal century. They have abandoned the anatomy. They use the universal century. All the universal century, they missed use the universal century. So, okay, and in 0093, there's a man called Shah example. He is disappointed about how the government, the Space Federation, the corruption of the Space Federation is. And also he is frustrated about how the people live on this Earth. They do nothing but pollute all the Earth. And also they are something like the Shah said that the people who live on the Earth are weighted down by the gravity. They also are weighted down by the gravity. It means they are trapped in the Earth and don't thinking about anything else. Just watching the sight in front of them, don't think about the future. So he is disappointed about this situation. So he decided to execute a terrorist attack. He wanted to drop not one, but 2 asteroids on the Earth and make the Earth into a nuclear winter, and force all the humanity to whole humanity to immigrate it into the universe. This is what he planned to, and also, yes, and of course his formidable opponent is going to support him, and this is what this movie mainly about. Okay, so let's watch what the problem is. Sorry, wait. Okay, so the problem in this scan is quite simple. Why they want to stop the free fall of axis, or the asteroid names axis, and the Amuro, or the main character who driving this robot, want to stop it, but he used the push. He want to push an asteroid out of the orbit of entry to the atmosphere. So I think this is impossible. But in the beginning, I think we should think how big this asteroid axis is. So its plane diameter about here is about 22 kilometers. It's quite huge. And also the volume, using this simple model, it's come from the spherical cap, 2 spherical cap and 3 cone. And I use it, assume the volume of it is about 1.92 times 10 to 12 cubic meter. And about the density, because the axis is originally for the mining is still industrial. So I think it might be the M-type asteroid. Means it has contained mostly the metal like iron and nickel. So about this type of asteroid, it has a density of 4 kilograms per cubic meter. So it weighs about 5.16 times 10 to 15 kilogram. And this weight is about 680,000 times of the pyramid, or about 15 times of Mountain Everest. It's a lot of weight to enter the atmosphere. And also in the movie, there has shared by the axis from the Earth's Federation for 100 kilograms of gold. So I'm curious about what the price is. So it's about 484 million NT dollars. But this is the price of yesterday, but I don't know what will be in the UC 93. So it's just a little estimate.
Okay. So he bought this asteroid?
Yes, because the government is corruption. So they said Shah won't do anything, but Shah has been dropped a asteroid before Axis. But let's see, no, they won't drop another one. So, yes, they are terrible government. Okay, and about the height it has, before its entry the atmosphere, it had exploded two pieces. In the movie, they say the first pieces, and I think it's this one, is directly go out to the just gone and won't enter the Earth. But the big one, the real one, will enter the Earth for just for enter Earth for no reason. I don't know why. But this project is very weird, but it's hard to estimate. So I won't judge about this. Sorry. So I was thinking about the back of the axis, and it's travel from the moon orbit of moon, and with this equation just about the conservation of the energy, you can know that speed is around 10 kilometers per second. But in the movie, it has acceleration for twice, so its speed is maybe about 20 kilometers per second, I think. And then the entry angle, it didn't say what the entry angle is, so I just choose 20 degrees for, I don't know, it's just simple estimate. And also it separated, it started to enter the atmosphere in about 120 kilometers. Because of the flame, it appeared after about 1 or 2 seconds. So I think it might be taller than the altitude of the common line. The common line is 100 kilometers. So I think it's higher than the common line. So I chose the 120 kilometers to make this discussion. And also you have the new countdown, just the robots that push the axis, but it's not quite impossible, quite important, because its weight is just 63 tons. And its structure has 10,000 newtons of force. Okay, so we want to know where to push. Therefore, from the scan, you don't know where it will push the axis. So I choose 3 cases. First of all, it's against the direction. Case 1, when I forgot to say, when the axis enters the Earth, it has this direction of the velocity. And case 1 is against the direction. Case 2 is from the bottom. Case 3 is from the back of the axis. So I choose these 3 to watch what will happen. And because I want to know what's the trajectory, so I made a simulation program with MATLAB, and it just shows what the trajectory will enter the Earth, and then I wrote a common line and the Earth's surface. It's a 1-to-1 scale of the Earth. And with no external force, it will hit the ground in about 18.71 seconds. And what if we use case 1? Nothing changed. The acceleration is too small for New Gangdang. So it's impossible for him to stop the axis. And for case 2, case 3, the same acceleration is too small. It's impossible for them to stop it. So the little current right now is no, not single case can save the world. Sorry, it's for the Emerald soldier. Okay, so now I want to try to know if how much force will I need to push the axis out of the Earth. So I just have a goal to not to make the axis touch the ground. And I decided to assume the first and second cosmic velocity at 120 kilometers of altitude. And first cosmic velocity in late altitude is about 7.82 times 10 cubic meters per second. And the second cosmic velocity, or known as the escape velocity at late altitude, is about 1.1 times 10 to 4th meters per second. So for case 1, I just choose to, because it has against the direction of the moving direction. So I want to make it Vx at this direction, but with this external force, I want to X backward and with the velocity, the first cosmic velocity, and also make Vy, the y direction of dropping to the 0. And I want to make it before axis hits the Earth in 18.71 seconds. Oh, for the constellation, I have chosen Vx and Vy. And for the case 1, yes, it will successful make the axis flew out, but it needs about 5.56 times 10 to 18 newtons. Oh, I forgot something. Okay, so it's a weird trajectory to push out immediately. And for the case 2, I just change the direction of the external forces to just make the Vy, the dropping velocity to 0, and also before the Earth hits the ground. Oh, sorry, the axis hits the ground. So in this situation, I just applied a Fy in y direction, and it need probably about 9.8 times 10 to 17 newtons, and it will fly by like that. And for case 3, it's quite tricky. I need to redirection the forces, or it will touch the ground even faster. So I just bended it about minus 20 degrees and also make a Vy equal to 0. It's the same. So as it fly away, it will need about 2.86 times 10 to 18 newtons to fly by like that. Okay, the comparison. All 3 cases, the New Gangdang won't save the world. It will make a disaster. But if we have the infinity power of the force on the forces, the case 1 needs 5.56 times 10 to 18 newtons, and case 2 is less, just 10 to 17 in order. It's quite less, and case 3 needs a lot too. So for these 3 cases, I think the case 2 may be the most likely to save the world, maybe. if you don't think about the price or the money we got. And for configuration, I have for thruster that we had for humanity right now, but you know the scale is quite flat, so it's impossible. So the conclusion, case 2 is most likely to succeed the saving world mission. And it's impossible for this new government to start the axis, just not possible. But it's possible to push the axis away without any, but it's quite impossible, but it's possible. Okay, so it's my, thank you guys.
Very good. Question, comment? Okay, Jeremy?
In the case 1, 2, 3, the gunpowders need to keep force or keep push the asteroid?
Yes.
So
we don't calculate the fuel consumption, sorry.
I see.
Yes.
How did you define the asteroid is fly away?
I watch the Earth fly away.
You have some conclusion that asteroid will fly away, right?
Yes.
So how did you define that? Does that mean the asteroid have already escaped from the gravitational field?
Yeah, it has. The speed is from this one, and the speed of it is more than the escape velocity of the Earth, so it should go away. Because the external forces I give him is constant, so it will keep going.
Because if we want to say the Earth is safe, I think the asteroid should be escaped from the gravitational field. In this case, if the gunpowders have already lose all of the energy, possibly the asteroid will go back to Earth.
In this case, I don't think so, actually, okay. Because it has a velocity more than the escape velocity. So I think it will just go into nowhere.
And I want to suggest the case 4, that is, if we have some force to push the asteroid into the stable trajectory, I think that means the Earth will be safe.
Yeah. Oh man. For case 3, I want to do the same thing like that, but I didn't. Oh wait. No. If we just using a horizontal forces to the axis, it will still falling down to the Earth, because we don't use it. We don't think the Vy to 0.
If you want to do that, we need to calculate the potential energy and calculate the trajectory.
Yes.
It's interesting.
But the value will more than this, definitely, I think.
Possibly.
Yes.
But if you want to do that calculation, it's going to consider the air drag, because although you have already been.
I have considered air drag.
Oh.
Yes.
So use the value close to the current lines.
Density of air is an exponential function, so. But the common line, the density is too low, so it's not quite important, I think.
It's important for satellites.
I know, but the axis is too huge.
Doesn't that mean you will have a larger drag force?
Yes. Yes. Oh.
That's right. It's a further discussion. Okay, thank you.
Okay.
So where is this? So the height is 6.5 kilometers? Or no?
No, 120 kilometers above the surface.
Because this energy, the 10 to the 18 or 17 Newton of force, depends on the distance to this, right?
Yes.
If you find it far away, you only need a little force to change the orbit a little bit, then it's going.
Oh, yeah. But in the movie, it shows near to the Earth, so I don't think they can change the direction immediately. So I assimilate.
Okay. Where was it from the beginning? When he bought it, where was it?
Oh, okay. Well, I have a map, but it's quite old. So here. Oh, here. So in their world, there has lots of colonized space colony, and the place I think is about here near the L4. So I think it can travel from the moon orbit.
Where is it?
L4 is right here.
L4.
Lagrange point 4.
Well, I hope 22 kilometers is so big, so astronomers can find it if it's coming to the Earth.
Yes, but yeah, I know. But in the movie, the fleet is around the axis to protect it to arrive the Earth. The fleet under the star to protect it. Yes.
Oh, okay. It's protected.
Yeah.
Okay, interesting. Any other questions?
Okay. Yeah. Okay. Then let's go to the Kahoo. Hey. If anyone didn't go in? No. So begin?
Everybody?
Oh, okay. Okay, let's start.
Okay.
I'll do just some silly questions. 100 kilograms of the gold. Yay. Okay.
People remember.
Yeah, next. Eh? 100. I dropped the axis from above the common line. So 100. Okay, next. Next one. Meters per second. Oh, this is the first and this is the third. Oh, M type, metallic type. Oh, magnetic field, so, haha. Oh, okay. Oh yeah. Okay.
So I like Andrew's question. Can you show some of the questions?
Yeah. Some of question.
Does everybody know that particular method? Have you read that book for high school exams? Can you show some?
I try. Oh, okay. No, you can't. No, sorry. Maybe.
Is it possible to go?
Okay.
Go
To
around the quiz again?
and I think maybe I just show the edit page to the all questions. Yeah.
Maybe next one.
Next one, attitude. And
Maybe next.
how long?
For example, this one we know the answer without any knowledge. Did you know that? Because there are two numbers, 11.2, right? So one of these must be correct. If you look at the unit, there are 3 kilometers per second, right? And 1 meter per second, right? So kilometer per second must be correct one, right? So the answer must be green one. Without knowing anything. And then there was another one. Can you go?
Sorry. I think this one.
Well, this one is physics, but then maybe next one.
Next one.
I forgot which one. But then there are some questions that
So
I like that.
it's this. I think this one or the.
Or maybe this one too. So this one we can guess, right? So there's 17 and 81, right? So 18.13 cannot be correct, right? Because it has 13, it's weird. Then we have other 3 choices.
Oh, just silly equations. Maybe I think the price is the same as the, actually I don't know.
Okay, anyway, thank you, Andrew. It was a very interesting presentation. So I guess 22 kilometers